Me again. So I wanted to do another quick video about constructing exponential models. And this is the part where we actually come up with the equations, which is pretty nice and easy as well. So each time we're going to keep in mind that we're going to have a starting amount that we're starting with, our rate, and then our exponent with time in it. And if it's happening over a certain amount of time, then it'll be the number of times that it happens. So whatever we're starting with, I'm trying to write start in here and it's not working. So we're just going to pretend that I wrote that in there. Your starting amount, your rate, and then t divided by the number of times per year it happens. So in this case, we've got some element which is losing 10% of its mass. All right, well, if it's losing 10% of its mass, it originally has 100. It's losing 10%. What percent is left every time? Well, 90%. So our rate here is going to be 0.90. Okay? You always take your percent and then divide it by 100. And the initial amount, the starting amount, is 960 grams. So we're going to start with 960 in here. And let's see. Mass sampled. Oh, and then it says every 871 years. So that is going to go down here. Whoops. 871. And there's our equation. And that's it. We just type that in. So let me up real quick. 960 grams times 0.90 to the power of, and the funny thing is you always have to put, if you're putting more than one thing in the exponent, you have to use parentheses, because if you don't, what happens is, watch, t, and then all of a sudden, when I hit divide, it divides the wrong thing. I just want that division up in the exponent, so I have to tell it everything I'm about to type is in the exponent, t divided by 871 years. And you use parentheses to tell them that all that goes up there. Bada boom. All right, same idea. So my starting amount, let's look through here and read. Tallulah is talking about penguins. Oh, we love penguins. And it's decaying. Their population is going down by a factor of 8/9 every 4 months. And when Tallulah began the study, she observed there were 27,000 penguins in Antarctica. So 27,000, that's what we started with. The rate, it says that it's decaying by a factor of. And when they say factor, they are telling you the rate. You don't have to do any addition or subtraction there. And we're going to put in the exponent. In parentheses, t divided by how often they said it happened, every 4 months. Boom. Oh, I pushed the wrong button. Let's go back. It'll start me back on that problem again, I think. Oh, I picked the wrong constructing the models. Here we go. Yep, I just got to retype in what I already had. 27,000. And the rate was 8/9. And the exponent, you can hit this button or shift 6 and it'll put it up in the exponent. Parentheses, t divided by 4 months. There we go. All right, next. Derek is sending chain letters and asking them to forward them on. Oh, I hate those. The people who receive the emails gain 9/10 of its size every 3 weeks and can be modeled by the function p. All right, how much did he originally start with? Well, he initially, meaning starting, sent it to 40, so 40. The rate, they're telling you the rate here is 9/10, and it happens every 3 weeks. So the exponent here is t divided by 3. Because we're talking about weeks, t weeks. Yep, there we go. Oh, I did something wrong. Let's find out. It's gaining 9/10. So I wonder if they want me to change this. Gaining 9/10. So they have 100% the original amount plus another 9/10. The whole, this is like a whole pizza, plus another 9/10 of a pizza. So 19/10 might be what they want in there. Let's find out. Yep, that's what they wanted. Nicholas sent a chain letter asking his friends every 12 weeks. So I know the exponent's going to be t over 12. Number of people increased by an additional 99%. So that's 100% plus 99%, which is 199%. So that means that my rate, you divide your percents by 100, so 1.99 is my rate. The exponent is going to be t divided by the number of 12 weeks. And how much did we start at the original? He originally sent it to 50 friends. This guy needs to do something else with his life than chain letters. There we go. So we made a mistake that time, and if we want to do it again, we can. It didn't take too long. Let's try it again. All right, starting with 48 branches. Figure out the rate. Increases by a factor of 11/6. Now this is where I get confused because they said the word factor, so I think it should just be 11 over 6. Every 3.5 years, so I think it should be t divided by 3.5. Whoops, in the exponent. Don't forget parentheses. Ta-da! Alexandra branches on her tree, and she started with 52 branches, increasing by an addition of 2 over 7. Okay, so that is smaller than a whole. So I need to make sure I talk about the whole 7/7 plus 2/7 equals 9/7. So that should be what I type in here. It's 9 over 7. And every 1.5 years. So parentheses t divided by 1.5. Bella started studying again with the branches at 2.9 years. Number of branches increases by 83%. So it's 100% plus 83%, which is 183%, which makes the rate 1.83. And she started with 60 branches. And the exponent here is going to be t divided by 2.9. Carbon element losing half its mass. Ooh, they tricked us. Half. So they're telling us that the rate is a half. Every 500 or 5,730 years. And it starts with 741 grams. 741. 1/2. Oops. Exponent. T divided by 5730. Ta-da! All right, we did it. Dun, 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 dun. So the first 3 topics in this assignment are pretty quick and easy. And then the next 2 get a little tricky. So I'll do those in a different video.